Gentlemen, we've never had a chance to meet. My name's Jay Nichol. I built Mindful Hunter and a couple other things. I'll do a bit more of an intro when we do the kickoff, but maybe just a bit of an offline intro to both of you guys so I know who we're chatting with.
So I'm Bryan Holtmeyer.
Okay.
One of the owners, well, actually the main owner of Hammer Bullets. Steve and I started this venture probably 9 years ago now. The whole reason was to create a better bullet. You know, we shot a lot of different bullets. I'm talking custom from Africa to custom bullets here in the States, whether it be cutting edge or any of your top of the line copper bullets. We really loved how they performed. So we really liked the GS Customs, to be honest, but we couldn't get them. So we decided to get a lathe and put it in Steve's garage and went after it.
I love that. I'm going to leave this. Okay, we're kicking off because that's very interesting to me. Now, obviously, we put out a bit of a Q&A. So let me give you some background. So I am not a gun nerd. I'm more of an archery nerd. I do a ton of hunting. I do a fairly significant amount of rifle hunting, but I'm a pretty simple rifle guy. But on the podcast, I was getting a lot of questions and interest about the more technical elements of rifle hunting. And Colton is a friend. Colton is very experienced, and I love where we both really aligned was this kind of like non-sponsored, unbiased approach. I kind of make my name, and my main business is doing non-sponsored gear reviews. And so what we've done with this series, Guns and Stuff, is me and Colton teamed up. And my goal here is to try and break down the technical elements of gun hunting for the non-technical guys. And because I think the desire for people to understand how their weapon systems are working these days is higher than it's ever been before. And not everyone's got a reloading bench, and not everyone can, do everything custom. But even for those guys who are going to walk in and buy a more, stock solution, there's still a really deep desire to understand cognitively the science behind the weapon systems that we're using. I've seen Hammer kind of start to pop up all over the place. I think it was a very interesting during the shutdown because lack of availability started having people look otherwhere for other solutions. I think there's been a couple really big players at the top of the game for a long time, and that always creates a need for some people to have alternate solutions. But I'm also not completely in tune or up to speed with kind of Hammer's design philosophy. And even just that little story there gives me a little bit of a glimpse into the kind of purpose that you guys are driven behind at Hammer. But I would love, before we get into the technical Q&A, like what is it that you think makes Hammer different? Or what is your mandate or your mission statement at Hammer? Like what gets you guys out of bed in the morning to do this? And what do you think makes your product different from what's available on the market right now?
Well, this is hard to say, but there's a ton of luck involved as to how we found our copper alloy. And I think 90% of it is that. Okay. And the other 10% is our design. With the radius design, we eliminated quite a few accuracy issues or high pressure issues and terminal performance issues in a copper bullet, solid copper bullet. The design with the radius and stuff, you have less engraving pressure. And, I'm going to be honest, for some reason, they're way more accurate and way easier to find accuracy than a lead core bullet. That's the nuts and bolts of why our bullet works is I think 90% of it is the copper alloy, and we pretty tight mouthed about it. But I'm sure that there's other companies out there that have taken our bullet and cut it apart and sent it away for analysis and probably figured it out. But as far as we know, we're the only one using our alloy.
So for a layman like myself, is the kind of technical makeup or the chemical composition of that alloy, is that going to affect things like pedaling and fragmentation and other things that we find people talking about or complaining a lot about with how copper bullets behave and how they, basically how they behave once they impact the animal or on the way to the animal?
Yes, absolutely.
Okay.
Our copper alloy acts way different. We've tested a half a dozen other alloys that got recommended to us that did not do what we wanted them to do until we found this alloy, which again was luck. There's a long story behind that too, as to how we found it. It was pure luck. But yes, this copper alloy acts way different than any other copper alloy bullet on the market.
And what's your current product catalog look like? Because I know you guys are newer, you don't have a ton of SKUs, but what's currently available on the market?
Everything.
Okay.
Yeah, actually, we probably have more SKUs than some of the biggest manufacturers out there. We have over 300 SKUs. I've got over 400 bullet programs right now.
Wow.
Yeah.
How did you, like, without getting into the nuts and bolts or things you don't want to share, that's got to be a tough manufacturing, especially being a newer company. There must have been some struggles, getting that, keeping up to, inventory requirements with that number of options.
Well, we've always made a commitment to everybody that we would never get behind. So, I would say within the next year, we'll be buying more lathes just to keep up.
Okay.
As of right now, I don't see any of the SKUs going away. So, the more we produce, the more we sell. Well, we're going to have more lathes.
What are some of your more popular options? Like, what do you think you're known for right now? What are people buying the most of?
The new tip bullet, the HHTs are really doing well.
We got some questions about that, don't we, Colton, that came in the Q&A, I think.
Oh, yeah. Lots of questions.
Okay.
And real quick, you were asking about the manufacturing and trying to keep up with SKUs and all the different styles. That's kind of the beauty behind a lathe turned bullet.
Okay.
It only takes a few minutes to change out the head and the collets, and you can go from a 223 up to a 416. If you
that makes sense. That makes a lot of sense. Instead of like retooling an entire line.
Exactly.
Yeah.
There is no retooling. We use the same lathe for all of our different bullets. Now we have designated lathes for certain styles, so we don't have to, rotate as much bar as we used to. But that's kind of the beauty. I mean, if
somebody wants 5 bullets, it'll take 20 to 30 minutes to do it. Well, there's no other company out there, lead core bullet wise, that can do that.
What a great secondary benefit to the design, because I'm sure that wasn't the impetus behind like, oh, we're going to make a solid copper bullet because it's going to be easier to manufacture. But especially given the conditions everybody finds themselves in, what a fantastic secondary benefit.
Yes.
Hey, real quick, weird guy that just started talking randomly. Introduce yourself. I know who you are, but the audience doesn't know who you are.
I jumped in. I asked them both to introduce themselves, and then I got so fascinated at the origin story, I didn't allow the second introduction to occur. So my apologies.
Easy enough. My name is Eric Hoover. I work with Bryan and Steve at Hammer Bullets. Actually, I'm a custom rifle builder that met these guys at the Special Operations Wounded Warrior event, and they bought one of my prizes from the table, and basically the relationship just started there. Just kind of snowballed. They needed help. They were growing. I have the flexibility of, everyone knows, you order a receiver now and you get it in 6 months. Right. So there's a lot of downtime in the process of making a rifle. So I come in here, but it was a few days a week. Now it's 4 to 5 days a week, and help with most of the process of shipping and packing and dealing with that kind of stuff. Bryan is the brains and machine operator for the most part at this point. And then Steve, the other owner, does a lot of our computer and
answer an email,
customer service side.
So your background is a custom rifle builder. What's your background professionally, Bryan?
I've got a AutoCAD degree out of college. Okay. So I started there, and then after that, couldn't stand to be in the office. So I went back. Well, growing up, I was a farm boy and construction. every aspect of construction. So after I couldn't stand being in the office with the AutoCAD degree and a couple different jobs, I went out and worked construction for 2 years out of college until 2018, later than that, 20. And out here, I was in Montana. I ran a finish crew, finish carpentry, until I came in here full time, which was 4 years ago. 3.5 years ago.
Okay.
Love it. Construction, I guess, would be the biggest thing.
And then just like a side note caveat, what kind of led me to work here and then also use the bullets was, I have a 338 Ultra Mag that everyone recommends one particular bullet for that particular gun. I shot 4 animals in 1 year, and out of the same lot of bullets, I had 4 different experiences, from the nose bending over to the bullet exploding to the bullet working and then the bullet not opening. And that just, wasn't an option. If you put a good shot on an animal, the bullet has to work.
Right.
And then meeting Bryan and Steve and then changing over to their 260 grain bullet, picking up speed, terminal performance, it kind of turned into an addiction of everything. At this point has turned into solid copper hammers, just because of I've never had one fail. In the testing we've done here over the last 4 years, just internally between the 3 of us, I don't think there's another bullet on the market that I've ever experienced that I've never had a failure, except for maybe me making a bad shot. I have not had one fail yet. And I can't say that with anything else I've tried.
While you guys are on the subject of testing, what do you guys do? Kind of explain your guys' testing protocols, because I know we've had conversations and talked about it. Just everything you do, from your tissue testing, and then the gelatin. There's a lot of different stuff you guys have done. Just kind of walk us through like all the different systems you guys have in place.
So if I design a new bullet and, question whether it's going to perform at low velocity is the hard part. What we use, and we learned this from a guy when we first started, we had a bullet.
Sorry, can you repeat that for me? Because you just nailed, you have no idea how many DMs you just solved with that one little line. And I want people to listen real closely. What velocity was the biggest issue for you?
Low velocity, 1,800 feet per second is our goal.
Okay.
A lot of our bullets will open way lower than that, the shock hammer line in particular, but we want all of our bullets to open at 1,800. And the reason behind that, we feel that 1,800 feet per second is what it takes to kill an animal efficiently. And what I mean by that is that's the velocity of that bullet getting through the animal and creating that good wound channel.
Okay.
I'm not saying that a lot of the bullets won't kill an animal at 1,500 feet per second. I don't think it's very efficient or good.
And when you guys talk about getting the bullet to work, it's not just, you got some to work. That's where you guys are seeing the most repeated, reliable expansion of your bullets, correct?
That's correct.
So it's like saying, go ahead.
I'm going to continue on with testing. Anyway, we first started and we had, I don't even remember what bullet. I think it was a 3181 Hammer Hunter. We had a gentleman, one of our first customers, that was shooting this bullet, and he was testing it and telling us that it would not open at low velocity. He just thought he did not have a big enough gun. Well, that's when we had a 1 millimeter hollow point, and we learned a lot right there. It's too small of a hollow point. It takes moisture to get into that opening, into that cavity, to get it to shed those petals. And that's why we ended up at the end, when we first started now, we going to a 1.5 millimeter hollow point on all of our Hammer Hunters. So the media that we use, and he taught us, is a gallon milk jug full of water and newspaper, whether wet or dry, doesn't matter, behind it just to stop the bullet. That's what we use. And in that milk jug, we want to see everything happen. You know, the bullet open, we want to see petals shed, and you'll see that in the back side of the milk jug. You'll see exit holes of all the petals. And that's how we test our bullets at low velocity. But we also make sure that stability is up too. You know, you can take a 30-06 with a 10 twist and load it down in velocity to 1,800 feet per second, hit that milk jug, and it not work. Well, that bullet is not stable at 1,800 feet per second coming out of the muzzle. Mm-hmm. You run that bullet at 3,000 feet per second, it's stable, and it will maintain stable through the flight. So you have to use a faster twist barrel to do this testing to get that stability there at 1.5 and or above, and to hit that milk jug at 1,800 feet per second and make sure it works. So there's a little more than just shooting a fast twist. A fast twist is going to help testing these bullets, because the higher RPMs, the better that bullet's going to shed its nose and do what it's supposed to do. So there's such thing as when we're testing it is to being overstable too, twisting it too fast to get a good reading. Does that make sense?
It does make sense. I found it particularly interesting, the difference between the different methods you could use to have that bullet impact at the feet per second you want to test, and one getting it there with a stable flight, one getting it not, and how the difference between the two can be important for the results that you can extrapolate. I'd never really thought about that, but I guess having it leave at 1,800 feet per second is different than having it leave at 3,000 and hit at 1,800 in relation to how the bullet's actually going to hit.
You know, that's another way to test it. You could set a milk jug up at 800 yards and figure out your drops and your velocity and hit that milk jug with that 10 twist barrel.
Yeah.
And give you the same reading that I'm trying to do at 10 feet.
Right.
And to find somewhere to go do that on a daily basis is impossible.
Right. You're also introducing a lot of other variables. I get it. Like, there's a lot of stuff that could happen to that bullet between points A and B that would confound your test as well.
Sure.
And then I think one note you have to throw in there is what we consider good bullet performance is we want that bullet to go in. We want it to open up and within an inch and a half, and we want it to completely shed the entire nose and it be a flat nosed bullet, very similar to a dangerous game bullet, which actually will out penetrate a mushroom style bullet or some sort of a controlled expansion. And then the byproduct of that is normally we find that the petals radiate at a cone out from the shank and just create more of a wound channel, a bigger wound channel that can't close itself up. You know, so that the byproduct of what we wanted to happen when that bullet came apart is just helping in the terminal performance aspect of the bullet itself.
Can you talk to me a little bit about sample size? Because one of the things that I've picked up from some of our most recent conversations is that, you know, when it comes to sighting in or reporting given MOAs for given rifles, there seems to be a tendency in the industry for people to use sample sizes that are a little bit small to be drawing some of the confident conclusions that they're drawing. And when I talk to like the real professionals, they're using much larger sample sizes. What type of results and consistency are you guys looking to achieve before you're comfortable saying, listen, this is how this bullet operates, not just, yeah, okay, sometimes this is how this bullet operates?
So the HHT line, the Hammer Hunter tip, that bullet was designed and given out. We tested it for flight. We tested it in a milk jug. We proved that. We proved it in gel. Then we send it to, we have a friend in Australia that he's in Tasmania that he can test on animals. I mean, he has to harvest so many wallaby a year just so he can have cattle that they have grass, and it's
Right.
it's the numbers. The numbers are in the thousands of what he has to control every year just to maintain the population. So the HHT on a conservative number of animals taken prior to it being launched, with us going to Australia and that bullet testing over there, and then also in Oklahoma around hunting season, I'm 700 to 800 animals were probably taken before we launched it. And I think that is a conservative number.
Yeah, and that's probably with a maximum of 10 bullets designed, not the 50 that we have on the website right now. So that, we just start in the middle of the road. Well, like 26 cal or 264 caliber, the 125, that one's been tested a ton. Of course, the 30 cal, the 163, the 154. So probably a handful of bullets actually, turned us on to these tip bullets are performing way better than what we thought they would off the get-go. I'm not saying they're that much better than a hammer hunter, but the biggest thing I like about the tip bullet, it didn't really think about it until we started using it, but it protects the knee plat of that copper. On an open hollow point, that copper can get damaged, get a little flat spot on it, and it will affect how it opens on the animal. Yeah,
and that's across the board on hollow points too. That's not necessarily specific to just your bullets, correct?
That's correct.
Any hollow point match bullet, regardless. That's true for all of them, not just hammers.
Right.
Because I suppose it's not the hardest material in the world either, because you need it to have the ability to peel back and open up. Like, part of its nature is that it's going to be a little bit malleable, which would open it up to more like physical, dents, nicks, scruffs, etc., depending on, where you got it and how you treat it.
Yes.
Interesting. I never thought about that. So without getting into like proprietary stuff, what purpose, or maybe what is it that tip is doing, do you think, or what was the goal that gives it the higher performance?
Technically speaking, the whole purpose behind the tip is to chase BC bullet coefficient.
Okay.
I mean, over our hammer hunters, there's not a lot of difference.
Okay.
There is a difference, but there's not a lot.
Right.
And, personally, we've tested some of these tip bullets, down well below 1,800 feet per second, and they still open. So in a way, on some of the bullets, I'm not going to say all of them, it will aid in the terminal performance of that bullet. And what I mean is it opens easier, opens quicker. Okay. With the tip in there, it just kind of forces that tip to open.
That makes a lot of sense. Colton, I sent you over the Q&As beforehand. Do you want to maybe start leading us through some more of the we'll just see where the conversation goes, but I think you got better context to know which of those questions are going to be more important than anything else that's come in from your group as well.
Yeah. And one of the questions I get a lot, we got a couple actually, and here is, what characteristics of the hammer bullet seem to make it easier to handle for the hand loaders to find that load or to tune a load? Because I know when I first started shooting them, again, and Eric has built some rifles for me. He's being pretty humble. He builds a lot of the rifles that Hammer uses for a lot of their accuracy testing and hunting and stuff. So he builds an incredible rifle. And in our conversations, we start talking about hammers and trying some of them out. And my initial, experiences were, man, this is just like an easy button. It's insanely simple. How you just, put them 20 thou off the lands and fill the case full of powder and tune your, velocities through your powder charge. But the bullet doesn't seem to be as sensitive to seating depth, and it just shoots consistently across the board. I've been fortunate enough to kind of get some seconds, if you will, because, they run, QC on a lot of their bullets, and they'll be like, oh yeah, here's some bullets you can play with, or, they didn't make the initial test, right? You can put those bullets into the same load data and you see no difference, right? It just shows like their QC is really tight. on bullet shape and configurations there. But the bullets still shoot extremely well, even if it's their second, right? So what is it about the bullet in your design or the materials that you use that make it so easy to load for the hand loader?
It all has to do with the radius drive bands. And probably the reason the accuracy is so easy because it's the way the air flows over those radiuses. It really doesn't touch them. There's no sharp edges. They're sleek.
And when you say those radius bands, what are you describing? Because there's a lot of people listening to this podcast may have never seen a Berger bullet or held a Berger bullet. What specifically are you talking to on the bullet?
Okay, so the drive bands is what is going to contact the rifling. The drive band, the top of the drive bands is what's going to touch the neck of your case when you seat that bullet in the case.
Okay. So it's basically the shank of the bullet. There's some higher spots and some lower spots, for lack of better terms. Like imagine, if you will, I'm trying to think, a lot of copper bullets have those bands around them. The hammers aren't straight.
Do you have any there,
edges.
Colton?
Oh yeah, I've got a bunch of them here. Hold on, I'll see if I can hold one up.
And then we can explain kind of what we're looking at here.
Trying to get it.
Maybe a little bit out. Okay, so what you're dealing with there, most copper bullets will run basically a parting tool in and just give you a relief groove to allow the copper to flow into so you don't overpressure. And you're getting the bearing surface at that point. Most of them run 3 or 4 grooves.
These are the guys.
We run 4, 5, or 6 for the most part. And then we'll also make that top radius about a half thou large, which makes them, again, so easy to shoot in tight bores or loose bore barrels because everything has a tolerance. And by making them half thou bigger, a barrel that is slightly light or a loose bore, it still seals. And on a tight bore, you're not affected with overpressuring because there's such little bearing surface touching that material flows back into the void. And if you find a shank that's been shot, you can see that the valleys never get touched by the rifling. So it's only riding on those the top sine waves, if you will. So you're only touching a very, very small finite amount of copper, which reduces pressure. And we'll find that a lot of the times to find pressure, you'll be over what the book recommends. You know, that's why when we recommend loading, start low, work up, find pressure, and then back down a half a grain or so. Normally at that point, 20 thou off the lands. If that rifle was a half-minute gun, you're usually done.
And with that, the low bearing surface, kind of another question that has come up and is kind of related is that increase in velocity with a hammer bullet, right? Shooting a 143 hammer and a 280 Ackley versus a 140, say Nosler Accubon. You're going to, same powder charge, that 143 hammer is going to be quite a bit faster. What is that? What is that? And is that related to those bands?
Less engraving pressure. So that bullet goes down the bore easier. Pretty simple.
Yeah. So there's less drag on the bullet, which is increasing its velocity. And that's one I get a lot. And obviously, I know a lot of my followers and Jay's that I've messaged us both have mentioned that they actually have talked to customer service there, and you guys are really big on the speed kills, which is not a surprise to me. Was that a big part of your bullet design going into it, or was that kind of, hey, these things kind of end up working better with higher velocity, let's go lighter and faster? And how did that how did that come about, or was that part of the plan from the beginning?
None of that was a plan from the beginning. You just hit the nail on the head. I mean, we're just farm boys. We just started making these things and they worked. Well, a lot of the byproduct is of speed is the drive band design. You know, that was kind of just luck on drive bands, the design. We had no idea what we were doing when we first started, but it didn't take us very long to figure all that stuff out by doing a ton of testing. The drive bands, we call them parabolic drag reduction, PDRs. And that's exactly what it is. They're parabolic, they're round, and the drag reduction is quite a bit. On the average, we probably see on the hammer hunter line 50 to 100 feet per second gain, weight for weight, lead core to our bullet.
Gotcha.
Do you actually get less fouling in the barrel because you have less drag and less surface area touching? Because I know that's one of the things people discuss with copper compared to other materials is that you are going to, have a bit of a dirtier barrel faster.
We see very little barrel fouling. Where it is an issue is there's so many different copper alloys out there and they seem to like welding to each other. So if you shoot a Barnes down your bore and don't clean it really well and get all the copper out, then you turn around and shoot a hammer. Yeah, that there's a possibility that the two coppers will mold together and create a pressure issue.
Oh, interesting.
So
okay.
That's across the board. It doesn't matter what bullet you shoot. You should always clean it down to bare metal before you start with the different bullet.
And then stop.
And that is a good point, because I ask a lot of people when they contact me about loading questions, hey, I started shooting these bullets you recommended, but I'm not getting them to shoot really well in my ladder testing. And one of the first things that I ask them is, are you doing an individual ladder test with, said bullet, whatever it is, because I have had numerous times where guys are like, well, these hammers aren't shooting for me. And through a series of questions, find out they were shooting 5 burgers and then 5 hammers and then, 5 Hornadies and then 5. And it's like, man, you can't expect good results if every 5 shots you're changing the copper alloy that's going down your bore, because now you're getting all kinds of different deposits that each bullet is going to react different to. And it's like, well, nobody ever, has brought that up. No one's ever said that. I've never seen anything on that. And it's just like, well, it's one of the things that I've observed in my time. And I know a lot of other guys have observed it. But it is interesting the number of guys out there that have no regard for the different alloys going down the bore simultaneously and the different results they're getting and pressure spikes. So going on to your point of cleaning the gun, it's just, if you're going to test any bullet, hammers or whatever, make sure you're starting off with a clean bore and don't intermix your bullets in your testing. It has always helped me when guys ask, well, how do you get consistent results? Because I've never had a hammer bullet not shooting any one of my rifles. Every one I've tested, from 22 cals to 375 H&H's for my Kodiak hunt last year, I have had insanely good luck with just picking the projectile I want, finding a powder that gives me the velocity I want, loading it up and shooting it. And I have not had any struggles, but I always have a system in making sure my bores are clean before I intermix, bullets and powders and stuff in that testing. So if that's consistent with you guys, that's a valid point.
You're 100% correct. And we get those calls every day.
Oh, I bet. Another one that comes up a lot. Why do you guys prefer the pedals to be shed versus, staying on the shank? I know we've kind of touched bases kind of around about in the initial conversation, but there's always that conversation as to, which is better. I don't personally think there's, a disadvantage to pedals being shed. I don't see it in my testing on my animals that I've harvested with the hammers. They all were insanely fast and lethal kills. So I don't see a downside to it. But I get asked it a lot, and hearing it from you guys, I think will just kind of help people understand it.
Well, Eric brought up the point earlier, shedding the pedals and then the dangerous game shank. The shank is what does probably 80% of the damage. The pedals do their own damage. But if you think about that shank going through the animal backwards, what I'm saying about backwards, I would bolt tail first with that flat front. If you think about the energy that is being displaced or the materials that's being displaced, it is transferring that material 90 degrees to the shank. The wound channel is much bigger doing that versus a bullet that mushrooms out and has a round front on it and parting its way through the material. Does that make sense?
Yep.
Just trying to explain it as well as I can.
No, I think that covers it. Covers it well. And then you guys is specific. I know in our conversations we've had, your alloy, the system that you came apart with, or the composition you guys came up with, lends itself to tearing those petals off and shedding them, versus some of the other coppers that it's softer and kind of holds together, causing that mushroom. Is that where that comes from?
Yes.
I mean, aside from the boat tail, it's more of a materials thing is what I've tried to explain to people. It's different copper versus different copper, not necessarily a design.
That's correct. Something else, I know that our hollow points are drilled deeper than most. We drill them to as deep as we want it to shed the nose. I know some of the bullets that we tested in the past, they drill a 1/4-inch hole, and they still want the petals to shed, but they would tear off. They would drill a 1/4-inch hole, but the petals would shed off down to a 1/2 inch, and you end up with a pointed bullet after the fact. Some of the stuff we tested, and we've tested that on our stuff too. It does the same thing. So that's the benefit of drilling that hole deep, is we can tell that bullet where it's going to shed that nose down to.
And in your guys' bullet line, one question that I got, and I think Jay got as well. We got a lot of what's your what's your most popular, what's your preferred, bullet, and a 300 Win Mag or a 7 PRC. Instead of going through the cartridges, maybe talk to what are your biggest sellers and what are your guys' favorites in the 264, 284, 308, 338, in terms of most popular for your all around sales or big game hunting. Cause I mean, that's where most guys are with your bullets. It's a hunting bullet. It's not a,
Yes.
A match bullet. It's not you can shoot matches and you can do whatever you want with them, but it's designed for hunting, in its entirety. It's not a, mixed bullet like some are, a match bullet that people start to use for hunting. It's designed specifically for hunters. What are your biggest sellers and most common if someone is going to call you guys and ask, hey, I got a 7 PRC, what bullet do you guys recommend? And the standard twist rates for those cartridges through the whole lineup of calibers.
That's a tall order to answer. The 264, the 125 tip bullet's probably our number one seller. The 124 Hammer Hunter was before that. And to be honest, the biggest reason for that is everybody wants to shoot heavy, and that's an 8-twist bullet, and 99 to 100% of your 6.5 Creedmoors are an 8-twist, and everybody wants to run that heavy of a bullet. It wouldn't be my personal choice in a Creedmoor. I would go down in weight to get the velocity up. Of course, yes, we get these calls every day, and the first question I'll ask is, what's your effective hunting range? And quickly through my head, I'll just come up with, impact velocity at 300 or 400 yards. If they're saying they're going to run a Creedmoor at 500 yards and shoot whitetail, there is no reason for them to run that 125. It creates more recoil. The velocity is less, which means it's going to have more wind drift. Why not run the 118 or even go down to the 110 or the 112 now, or the 100 or 112? Get that velocity up and get a higher impact on that animal. So that's another way to look at it.
Yep.
So you mentioned the 7 PRC. Yeah, that's a hot item right now. Steve ran that last fall, elk hunting. He ran the 170 tip bullet, the HHT. Of course, it performed very well. I would personally take that cartridge and run on the heavy side. It would be the 153. Get that velocity up to 32 to 3,300 feet per second versus 3,000.
And the 30 cals and 338s, what are your common or
So the
picks?
30 cal would be, of course, the 10 twist bullet would be the 182 HHT. And the 338, we just came out with tip bullets for that. Up in the Lapua range, probably run that the bigger, the 245 or the 260 Hammer Hunter that Eric's running. Down to the 338 Win Mag, I would not run anything heavier than a 210.
And I got some questions on the 210. I actually got quite a few questions. A lot of guys are starting to run, 338-06s, 338 wins. And some of the guys are even running 338 rums or 33 nozzlers. And we're looking for the lighter copper options to increase the velocity. And that 210 came up quite frequently in their questions. So that is a popular choice that you guys see.
Yes. That 210 has been a struggle for us, or for me designing it, to get that nose to shed, because I based it on the factory chambering, the factory magazine length of the 338 Win Mag, and that nose is very short. And to get these bullets to perform, that nose comes up so quick, the material gets thick quick, and it's hard to get that bullet to open. So, and I've got a 190 that I did. It will not function correctly, so I'm going to go back and revisit that. The 338 Federal, a smaller cartridge, has to have that short of a nose. It's going to be a struggle to get a bullet to work. But that's what we're here for. Every bullet that we're going to put on the website, it's going to work, or it won't go on there.
So just to cover the back end of that a little bit. So what happens is when you get too short of a bullet, you don't have enough energy in the shank to push it forward and cause it to open. So everything can be the same, but if it's not long enough and you don't have enough retained shank, you're not going to shed the petals properly like we want them to. Like he said, the 210 was a struggle. The design changed. Some more factors changed. The boat tail length to try to get the weight up a little bit on that back side and thin the nose. And we've got it to where it does work. That's why it was launched. But Brian, you started on that a few months ago.
6 months ago, probably.
Yeah, tinkering with it, playing with it, shooting milk jugs at low. Everything's working at high velocity.
Sure.
That's not what we're worried about. We're worried about the 1800. We're worried about the bullet has to shed 100% of what we want it to at the low velocity, or it's just not going to go on the market. There's not going to be a compromise with terminal performance. So that's kind of, Bryan, yes, mission statement. And since I've been here, that's always been the driving factor, is if it doesn't perform terminally, it doesn't matter what the BC is, or it doesn't matter how well it shoots. It has to open on game.
That's a very interesting limiting factor, because obviously that's going to affect, it introduces limits, because you can only get so light because you're limited by your diameter. And once you run out of weight to put in that shank to force those petals to open, that's a bit of a wall.
It's a double-edged sword. It's tough on some of these bullets to get them to work properly.
Yeah, that's interesting.
And that's the beauty about doing CNC. Bryan can sit here on his computer and come up with, if we somehow could get a range inside the building to test at short distances, we legitimately could test 15, 20 different bullet designs a day.
Yep.
Right.
So just in our manufacturing facility, there's no room for that, and we can't do that. But in a perfect world, that's what it would be. You design the bullet, he has a lathe, it's shut down for the day. It's only going on the design process. Load it up, take it out back, shoot it. And then you could come up with a quick bullet design that we know is going to work. And then we go and send it to people for testing, make sure that's going to work. And then it gets, released. So that's the beauty of doing CAD and the CNC is we can exponentially change anything we want at any point. A lot of manufacturers can't do that.
That's one thing about your guys' setup, and I've been down there quite a few times and checked it all out. It's kind of hard to understand. Like I've toured buildings and I've seen how lead, cup and cores are made, and the simplicity of your guys' process is pretty immense. That it's just those lathes and stacks of copper tubes, or not tubes, but bars, and how that system works is incredible. And you guys can just produce extremely consistent bullets just based on the nature of a lathe turned bullet, and the ability for you guys to modify those slightly and test them is I don't think it's matched in any other part of the bullet industry outside of lathe turned bullets. The ability to constantly be evolving and making a better product, or at least trying to improve a product over other areas in the bullet manufacturing. Would you guys agree?
100%. But like Eric said, this process would go 10 times faster to come up with a bullet design that works if I could shoot it right here instead of taking it home. Going outside, setting up a milk jug, get a chronograph on the gun. To test one bullet, it takes an hour. And then it doesn't work. Well, then I'm back to the drawing board, which is another day at the shop, and I go back home that night and do it all over again.
Well, or you can just call me. I'll come pick up the bullet. I'll go shoot the milk jug. Because I'm just down the road, man. I'm just down the road. I'd be more than happy to shoot those milk jugs for you. I know they can be burdensome at times. One of the other, again, back to the questions on bullets and stuff like that. For the guys that don't reload, I mean, there's a large populace of people that do not reload. Where can people get your bullets loaded in factory ammunition so they are ready to shoot?
Oh man, I wish I had the list. I don't have one sitting here in front of me. We have a handful of companies that use our bullets in their ammo.
Hendershot.
Hendershot's is one of them.
Out of Maryland. They do a lot of custom loaded ammo. Unknown
Munitions.
Idaho. They buy our bullets and load up for customers.
Of course, Weatherby.
Weatherby's the biggest one.
Yep. Gunworks uses Gunworks does it, yes.
Evolved.
Pendleton does it.
Okay.
Evolved Munitions does it.
So they can go to your website and there's a list of it, correct, on the website?
Well, the easiest way is just to send us an email.
Oh, okay.
And then we'll forward them the list.
Oh, okay, gotcha. I know I saw some of it on the website, but
that's probably something smart. We should probably do that. As far as I know, it's not on there.
Oh, okay. So email you through the website, and they can get that list of where they can order the ammo.
Yep.
And do you know if there's any of those companies, are they sending that ammo? I know bullets go north of the border to Canada. Do you know if any of those companies can ship to Canada? Or
I know for a fact Gunworks does.
Gunworks,
because there were some animals killed up there, and we asked the question, where did it come from? Well, it was Gunworks ammo.
Gotcha.
Might be through I should ask too. My buddy's a Gunworks distributor, Precision Optics, out of Cornell. So I know you can bring up guns through distributors. You might be able to bring up ammo as well. I'm not 100% sure about the like a sole individual ordering ammo across the border. That's a really good question. I should look into that actually.
Yes, you should.
Yeah.
That's a Canada thing.
Yeah,
right.
It's a Canada thing.
Man, I think we got through a lot of the questions. I know a lot of the guys are asking caliber specific and cartridge specific, which is so, like you said, I always ask them the same thing. It's just kind of, what's your max ethical effective range for you with your system, and what are you hunting? And then I kind of back extrapolate impact velocity and kind of go from there. It's the same thing I give people on all bullets and so forth. So we could be here all day. I know we're approaching an hour going over.
I think one thing,
going over those cartridges. Yeah.
One thing I'd like to bring up, and we've talked about this in the past, is the amount of engraving that you get on a bullet. from different rifle to rifle, even same barrel manufacturer, how that can affect, especially with copper bullets, how that can affect the BC. And I know that's of going into a higher level of reloading and, going down a rabbit hole. But that being said, I don't care if you're using a lead core bullet or if you're using our bullet or another competitor's copper bullet. Running a ballistics table in a chronograph is not enough. If your ethical range is 500 yards, you need to make a custom drop table for yourself or verify, because we've had 2.65 284s, I believe, that same bullet, same load, same speed at 800 yards. I think it took another MOA for the other rifle to get to what the other one was doing. And all that is due, same chamber, same reamer. All that has to do with the difference between the rifling from one barrel to the next and the type of engraving of where it hits the bullet. So it might hit 5,000, 6,000 before the other barrel does. Well, now you're increasing drag on the bullet. So there's a lot of things that can change the BC, and I don't think that's not driven home enough of how BCs can vary. Everyone just looks at the table and says, well, that's what it is. What's the problem? Why isn't my gun hitting correctly at 800 yards? There's a lot more to that than just JBM ballistics.
Yeah.
And scope dials, all scopes, it doesn't take much for that scope dial to be off. One MOA at 800 yards is not much when you're dialing 20 MOA. It doesn't take much for that dial to be off, and you're going to be, that could be the difference between the two guns. There's just too many variables. Every bullet, every gun combo needs to be tested at the effective hunting range.
I agree. And I know you guys, I know a lot of people ask, well, how come their BCs are so low? I know you guys get it a lot, and we've had conversations about it. And it's just this huge marketing driven machine of high BCs, sell bullets, right? Because it just, high BCs makes it drop less, it makes it drift less. And everyone's just focused so much on high BC that everyone kind of automatically goes to larger, heavier bullets with a higher BC. So it's just like kind of an easy button, not necessarily equaling terminal performance downrange just because it has a high BC. Second to that, most guys realistically aren't shooting far enough for it really to matter. I think if guys are really honest and sat there and looked at the numbers, I still think everybody's sub 500 yards on 90% of the animals harvested in Canada and North America. Inside 500 yards, there's no point in running anything but a copper monolithic, in my opinion, after shooting them the last couple of years. The difference between that bullet at 100 yards and 500 yards, its terminal performance is unmatched in most lead core bullets. Maybe some of the bonded stuff will perform and hold together and penetrate as well and create a good wound cavity. But with everybody chasing these high BC match bullets, then they shoot something at 150 yards, which is far more realistic than the 1,000 yards that they're planning their whole rifle setup around. And they're like, oh, the bullet pancaked and grenaded up on, on the shoulder or on a rib or whatever. I got no penetration and, the bullet failed. It's like, well, actually you failed. You chose the wrong bullet for the mission. And it's not I'm not just touting, hammer specifically just because I'm talking to you guys about it. It's picking the right bullet, regardless of the BC, for your intended application and for your intended hunt, and being realistic about that expectations. I know Jay and I have had numerous conversations about setting up for success for the hunt based on what's realistic and being honest about it. And man, I honestly, like talking with, Eric recently, a 300 Win Mag with 181 grain Hammer Hunter with a case full H1000. Like, dude, give me that and I'm set. I'll take anything on in North America and not even question it. It's a phenomenal combo that I've been shooting a bunch of lately. And it is deadly accurate. And the performance of those bullets is just awesome. And it doesn't have a great BC, right? It's not the high BC that one would want, per se, in today's market, but I don't need it. It's a 600 yard rifle. It covers 99% of my hunting applications to the T. And I think people should take a better look at hammers and copper monolithics, not just because of the lead, stuff that's going on in, certain states or whatever, but just for the performance on game across the spectrum.
I agree with you 100%. I've always said, the BC doesn't really matter until you get past 500 to 700 yards based on the cartridge. It does not matter. Well, 90% of your animals are killed in less than 300 yards. And I'll tell you what, when we started, 300 yards was a long ways. 300-yard shot's a long ways on an animal. Unless you do your homework up front and, of course, reload. Do your testing at that range to make sure that you can make an ethical shot on an animal.
Yeah, I think it still is a long ways for 95% of the hunting population. I think, and I'm not a long range guy, but I'm a content creator, and I do think YouTube, social media, and content creators started giving people unrealistic expectations for what. Like, I'll be honest, I fell victim to this. I built my Fierce to be like a 800-900 yard gun, and it's like, it's capable of it. I'm not. I'm not gonna shoot anything 800-900 yards away. I mean, furthest I've ever shot an animal is 328 yards. And yet I have this gun that cost and was designed in order to do something that I'm never going to do with it. I remember I sold my Tikka T3X to buy this Fierce, and it like, everybody's asked me like, would you do it again? And the answer is no. I had a $1,000 Tikka T3X 300 Win Mag, shooting factory ammo, flat as a pancake, no problem. Out to 4, I could hit a 4-inch steel at 400 yards all day, every day. And that gun was a killer. It was a tank. It did everything I needed it to do. But you start, what if I get in a situation where I want to reach out a little bit further, start goat hunting, and think I might have to go across canyons and stuff. So get this big fancy gun, and it doesn't do anything that other gun didn't do. And, arguably the ammo I have in that gun right now is not ideal for the distance and the velocity that I will end up shooting an animal at. Now, it does okay because it's a 300 PRC, and I think you get a little bit of leniency when you start using the bigger calibers. But this is one of the biggest misconceptions I see right now. People are not building rifles and loads for the 95% of hunting opportunities they're going to run into. They're building it for the 5% of opportunities that they might run into. And what that is doing is creating a system that's not optimal for the situation that they're most likely going to find themselves in.
You are correct.
And then what people don't realize is, with the added speed of, let's say Bryan said, don't use the 170, go down in the 7 PRC. The added speed, if you truly look at the data and you go, okay, high BC bullet versus this one that is 40 grains lighter, but it's solid copper. If you look at wind drift and you look at MOA, a lot of the times the higher BC bullet doesn't take over until after your effective range.
That's correct.
I did that for a guy with a 7 Psalm. He was going to shoot the AccuBombs, and we went with the 155 Hammer Hunter. And like, what's your effective range? I think 700 yards. Well, we started running the numbers, true numbers, and we actually got an extra 50 feet per second out of the hammers than what we thought we were going to. The AccuBomb with the higher BC didn't take over until both bullets were below 1,800 feet per second. So, you're looking at a high BC bullet versus what everyone always wants to say BC. In real world applications, the 155 smoked what the other bullet could do beyond where they were capable of opening. So, the whole BC game has been a marketing tool. And I don't think it's just been something that's carried over from the 1,000-yard bench rest into the hunting world and maybe shouldn't have. But it's here, and that's what we deal with.
Another huge benefit I just want to throw out there of the hammer bullets is we have yet to find a top end velocity. So they will work at 5,000 feet per second down to 1,800 feet per second, guaranteed.
That's interesting.
There's not many bullets on the market you can say that they'll work at that kind of velocity range.
Right.
And also penetration. I mean, case in point, we were in Australia and I took a scrub bull with a
80 grain
6.5. And you're talking, a 800-900. It wasn't an adult scrub bull, but it probably approached the 1,000-pound mark. I shot that right side shoulder, broke the shoulder, passed through, broke the far side femur bone, and we found that actual shank stuck in the hide, poking out on the other side. Now, I don't know of any lead core bullet that's ever going to achieve that. And that wasn't even high velocity. I think it was 3,100 feet per second, 32. But just, everyone totes the heavy for caliber. Well, heavy for caliber is good. But if that bullet is getting a pass through and you're getting it to shed and that terminal performance is bigger on the inside because of the velocity, that extra weight in the other bullet did absolutely nothing to help you, maybe hindered you because of the wound channel being smaller because it didn't have the velocity behind the bullet. So there's so many different aspects that the copper world is so new into of what we're achieving that podcasts like this and talking about it and getting this information out might help some people, because it is a new process, and we don't like to change. It's really the truth. So, but anyways, that's just a caveat on a small 80 grain pill that should not have done what it did, but it did multiple times on that trip.
And I would not promote somebody going to Australia to take that combination. It was in his hand when we seen the scrub bull, and he shot it.
Good testing opportunity.
Exactly.
Do you have any thoughts or speculation on a discrepancy or a difference in performance between a bullet that sheds pellets and a bullet that doesn't, in getting a true pass through and getting hung up on the far hide?
First-hand experience is, and this is with a lead core, not with the Barnes, is like the Accubon and stuff. The biggest benefit of it shedding its nose, or another benefit, is the meat damage.
Oh yeah. Okay.
That lead core bullet, I don't know how to say it. The lead just kind of sprays. It gets hot and it melts and it disintegrates into the meat, into the animal. These hammer bullets will not do that. They're solid copper. The petals they're going to be the petals, but you're not going to have a million little bitty pieces that's going to spread throughout the animal.
Right.
And that's something I talked about with Eric this last fall. Everything I shot was with a copper monolithic. Most all of them were hammers, and I think Barnes CXs were some of the other ones. And I definitely put more meat. I'd like a noticeable amount of more meat in my freezer, just from lack of meat loss from lead core bullets when they hit bone. Because having had lead poisoning and still dealing with lead in my blood, I'm a little bit more concerned about it than most. Most people kind of laugh at it and kind of say, "Oh, it only matters in California," until you've actually had lead poisoning and had to deal with it. But it is interesting to see, like, when you shoot something with a hammer. I mean, I shot some does this year, very close range with the 280 Ackley, like high velocity. I think it was like 3250. I think I was getting those, maybe 3300, 3250, something out of those 140s. I can't remember. And it was devastating, right? But still got pass-throughs and all that stuff. But the bloodshot on the meat just scrapes off. It's not like the lead that when it's just through the meat, you just have to cut off, just massive amounts of meat and just get thrown away because it's just bloodshot and there's just lead. Just you can see the lead veins throughout it where it's just running those little tiny microscopic pieces. And you don't lose the meat. Even if you hit bone, you don't lose the meat. You just cut around it and scrape off the little bit of, jelly, bloody stuff that's on the outside of the meat, but it's not driven through it. And I'd never really seen that before on copper copper bullets in the past. I didn't pay attention, or I didn't have a whole lot of experience with them. But it's something that I think a lot of people would benefit from. Just that knowledge of that alone, is the amount of meat loss from those copper bullets is negligible. Even if you hit bone, it doesn't matter. You shoot a sheep in the shoulders, or anything in the shoulders, you're not going to lose that shoulder. Just a chunk of it where that bone exploded, but that's it. It's pretty unique.
That's interesting. I got a bunch of bear hunting coming up here in BC, and we're very big front shoulder guys when it comes to bears up here, because you don't want them diving off into the vegetation. Unless I'm in archery tackle, then I go center. But you're basically giving up that whole front quarter. Like if I smoke a bear with an ELDX out of my 300 PRC, that whole front shoulder's gone. Like it's just vaporized. And it would be interested to see what that would look like with a copper monolithic. I'm sure it would be significantly less.
You come up with the test media of 2 animals standing there side by side, and we'll make it happen.
All right. I love it.
We've often thought about how to do that test. It's almost impossible.
Yeah, for sure.
But I know there would be a huge difference. You would noticeably be able to see the difference. Easy.
Yeah. Yeah, well, and
you can
even
still
Colton
see it,
talking
though.
about that lead spray, like that's what happened. Like, I shoot LDX in my 300 PRC. Listen, they animals die. I'm not going to say that, but there's definitely you're paying a price for it, because you do get that kind of catastrophic impact and meat loss, and you can just see the spray of the material through the meat. Like it's not a big fragmentation. It's literally like almost aerosolized lead. Like it just sprays through wherever it hits when it comes apart on impact. I want to thank you for your time, gentlemen. The deeper in it, it's funny. I opened the podcast by saying I'm a diehard archery guy, but like the more time we spend with this, with these rifle podcasts, the closer I am to getting a reloading bench and moving my bow press kind of off to the side. Cause I do find this stuff really fascinating. And I love that, guns and bullets have been around for a long time, and just some guys who gave a shit, were able to come up with some bullets that clearly are operating in a pretty significantly different way to some of the other options that are currently on the market. I'm super impressed by that and super fascinated by that. So I appreciate you guys taking the time. I'll give it back to you to close out. Obviously, I'll put links to all the hammer stuff in the show notes. But if there's anything that you want to share about products coming down the line, or ways to get in touch with you guys, or things people should keep an eye out for coming up, the floor is yours. And thank you again for taking the time.
You're welcome. We will continuously be coming out with these new tip bullets. Right now, we just came out with the bigger one. So it's working in probably going to be the 8mm on the small side. And I haven't found the top side yet, but I'm hoping to get through the 4.16 calibers. Of course, it's going to take a lot of testing and time. And I'm really not a big hurry to get that stuff done, but it will be done before hunting season gets here. So probably August, September, somewhere in there. So that's something to look forward to, is the bigger tip bullets.
Okay. Sounds good.
I can't think of anything else that we've got in the hatch.
No, just,
Eric, do you want to give a shout out to you? Are your books are probably full up as it is, but if you want to give a shout out for anybody looking for a builder, please do.
Yeah. So, Hoover Precision Rifle is my company name. You can find me on Instagram and your social media platforms. Build a rifle, usually to the specs of what the customer wants. Me and Colton got a couple, one coming down the pipeline right now that should be pretty fun to play with when it finally gets finished. But no, accuracy, that's kind of the name of the game, build what the customer wants, try to, if they don't know exactly what they want, steer them in the best direction for the most suitable gun of what they're going to go hunting. And then one thing we didn't touch on, but the biggest thing changing in the custom gun world, I think Colton would attest to this, is twist rate on barrels. We're stuck going slow, and that's been a necessity for years because of lead core bullets. That's the biggest thing. I make phone calls daily because people want a heavy 6.5 bullet and they'll order a 137. Well, that takes a 6.5 twist. 1% of the population has that. And that's that one guy that ordered a Bartline 6.5 twist. So for our bullets and anything, check the twist rate. Make sure your gun is achievable, because even if it shoots well in flight, the terminal performance might not be there on the animal because it hits slightly with a yaw. So me being a custom gun maker, someone wants a 300 Win mag, there's a good chance we're going a 1 in 8 because there's no reason to go with a 1 in 10 anymore. Let you have that option to shoot all the lead core and all the copper that you want to, so that's just to come back around a little bit, something we didn't touch on. Twist rate is everything.
Yes.
Keeping it above 1,800 feet per second and having enough twist.
And that is on our website in big bold letters, and we still get the phone calls every day.
And one thing too, onto Eric's gun building, a lot of guys build guns. There's a lot of gun builders out there. There's not very many that will build on Mausers, Winchesters, Rugers, Tikas. What else have you built on, Eric? I know you've had some wild actions in there that I don't think most builders today would or could build on, because it's not a common mainstream thread pattern for them to know. So anyone out there that's got, like I said, a Mauser, 364, post 64, any of that stuff that's not a Defiance or a custom action, he does that work as well. But he has a lot of work for me that a lot of builders won't do because it's, a Winchester or a different action, and they don't want to mess with changing their thread pitches and patterns. And so just one of the different things he does that's marketable. I think that people need to understand.
Custom rifle builder, but kind of along the lines of the 1960s and 70s custom rifle builder, of not getting stuck. I mean, anything from high-end wood stocks to bench guns, the F-class guns, to, your standard, what most people want is a carbon stock, carbon barrel, lightweight hunting rifle. I'm a gun guy, a bolt guy. If my lathe can cut it, it's not that hard. People think it's some weird science. My lathe spins in a circle like everyone else's, but it's really about checks and balances and knowing that everything is done the same way every time, and that way works. So that's really, and like you said, Mausers, you had to bring up Winchesters. I love cutting those extractor slots in those, but if it's a bolt gun, we can make it happen.
Well, that's awesome, guys. I'll put all that information in the show notes, and thanks again. Deeply appreciate it.
Thank you.
All right. Cheers, guys.
Cheers, sir. Later.